is that we are going to take and go through some things we've started before, which is when we were given zeros of a polynomial to try and find what that polynomial function is. So our first example today is something we've done before, which is I've given you the zeros of 1, 2, and 3. These are all zeros of a third degree polynomial, and we're going to try to find that polynomial. Well, we know that if those are zeros, then these are equal to 0. X equals negative 1, or positive 1, x equals negative 2, x equals 3, and then of course we know that that's equal to x minus 1 equals 0, and x minus 2 equals 0, and x minus 3 equals 0s. Once we've come to zeros, we know we have these factors. Now we take the factors and we multiply them together. So we'll have x minus 1 times x minus 2 times x minus 3, and that's going to be our function. Now we have to multiply those together, and we multiply the first two pair together first, and I get x squared minus 3x plus 2 times x minus 3, and then I multiply the final two together that are there, and I get x cubed minus 3x squared minus 3x squared plus 9x plus 2x minus 6 equals my function. And then finally, combining all like terms, we know we get x cubed minus 6x squared plus 11x minus 6 equals our function. So this is all things that we've done before, so it shouldn't be new to us. But today we're going to try and take it to the next step. Now, if anyone needs to pause this for a second and have someone help to explain what's going on, then please do that. If not, let's go on. Now, the next thing that happens is that we get a situation where I'm giving you 3 zeros, negative 2, positive 2, and I. And I know it's going to be a fourth degree polynomial. And the last bit, which is also very, very critical in this, is that f of 3 has to equal negative 150. Alright, so now the problem comes in with there being an I. If you notice that we only have 3 zeros, but it's a fourth degree polynomial. So we know how many zeros we should have, especially since we're counting imaginary ones, should be 4. So this comes into our new part today, which is that when we are taking imaginary zeros, its conjugate is also a 0. So its conjugate is also a 0. So now they always come in pairs. They always come in pairs. So now when I go from zeros to factors, I have x plus 2 equals 0, x minus 2 equals 0, x minus I equals 0, and x plus I equals 0. And so in turn, I'm now going to take these factors and multiply them together. When I do that, then I get x plus 2 times x minus 2 times x minus 1 times x plus 1. And I get a grand total of x squared minus 4 times x squared minus I squared. Now, of course, I know that I squared is equal to negative 1. So now that gives me x squared minus 4 times x squared plus 1. And now I go ahead and multiply these together, and I get x to the fourth plus x squared minus 4x squared minus 4. This is my function. However, I've got a problem in that I have to try and find out if f of 3 will equal negative 150. So I have to plug in 3 into this function that I have and see if it equals negative 150. Well, when I do that, I get f of 3 is equal to 50, which definitely is not negative 150. So the question I got to ask myself is, what do I need to multiply 50 by to get negative 150? Well, obviously, at that case, I'm going to need to multiply this over here by -3. So if I'm going to multiply this blue step, the 50, by -3, I also have to multiply the red part over here by -3. And I get -3 times x minus 4, or x to the fourth, minus 3x squared minus 4. And then I just distribute the -3 inside. And then I get a final function of -3x to the fourth plus 9x squared plus 12. So this function here will give me the two zeros of 2 and -2. It'll give me the two imaginary zeros of I and -I. And when I plug in 3 for x, it'll give me -150. If you need to pause and help each other out by taking a look at anything, please do so now, and then we'll get ready to go on the next slide. So if you want to pause, go ahead and pause. Now, the last example I'm going to have here right now is one where it's going to be a fourth degree polynomial. My zeros are 1/2, -1/4, 2 plus I. It's a fourth degree polynomial, and f of 1 has to equal 20. Now, what I want you to do is I want you to try and work through, maybe help each other out, to see what you think this one is going to be equal to. Okay, what the function f of x is going to equal to, they'll have this scenario. Okay, I'm going to pause, and then when everyone's ready, when you pause it too, and then I'll show you all the steps and talk about some things that are here. So go ahead and pause, work on this problem, and then we'll start it again. Alright, we're back here now, and here are our steps that we see. Here, the situation is that my 2 plus I has to have a conjugate of basically 2 minus I. That's its conjugate, 2 minus I. So now my factors, remember, to bring everything over. Now over here, what sometimes is tricky is that when you have zeros of 1/2 and -1/4, you're working backwards in your solving process. It's not going to be x minus 1/2. You have to first multiply both sides by 2. That has to equal 1. And then you bring the 1 over to give you 2x minus 1. Over here, you need to multiply both sides by 4 to get 4x. Then bring the -1 over to give you 4x plus 1. Now, here are your 4 factors that you have. Here are the 4 factors. Multiply all this together. Simplify all your like terms. Put your imaginary parts together. And as you're working through, then you get a result of 16x to the fourth minus 68 plus 94x squared minus 12x minus 10 is what my function looks like. Okay, now I haven't tried, and I'll let you try on your own. Well, what says f has to equal 1? So I guess I put in 1 at all these places. Let's see, that would give me 16 minus 68 plus 94 minus 12 minus 10. You guys can figure that out to see if it does give you 20. If not, what do I need to multiply this by? Well, I need to multiply this one by 2. So obviously this came out to be 10, and this one's going to come out to be 1 that's there. Or I should say it's going to come out to be 20. Alright, so the blue step, when I plugged in 1, gave me 10. The black step here is multiplied by 2 to get my 20, and then all is good. Alright, so this is what you're going to be working on this evening, is including these imaginary parts for zeros to get your functions. So here's your assignment for tonight, page 336, 17 through 32. Make sure you show all the steps that you've seen here, and Hope things all work out well and help each other out along the way. Alright,